Hey everybody, welcome to another HashiCorp Sydney talk. Today I'm joined with Ben Poe and we're going to be speaking about how to create a AKS cluster in Azure. Ben, would you like to do a brief intro, please?
Hi everyone. So yeah, as Brad mentioned, this is going to be an introduction to creating an AKS cluster using purely with Terraform. In today's session, we'll actually be showing quite a few things that involves modules, which is something that we had spoken about before in our last Sydney Terraform group chat. So I've got the link to this, to our last chat, and I'm just pasting that up. I'm not sure if that actually showed up. Brad, could you pop that up on screen?
Sure.
So this is the last session that we had. And for anyone that's keen to learn more about modules, feel free to watch that previous talk and they'll get you up to speed on how we've been doing things. So, all right, back to you, Brad.
Yep. Thanks, Ben. So for this, we have two Git repos that we've made. So what Ben and I like to refer to, we like to call level 1, level 2. So the Terraform modules that we use, they're in this repository here. It's under, I'll just chuck that on the screen as well. So this is GitHub Vermiculate Terraform hyphen modules. So this is where we call all of our modules in our level 1. So we've referred to this as level 2. And you can see here that it contains all of the modules that we're going to require today for spinning up AKS Cluster. And also, this is a public repository, so feel free to clone it or fork it if you like. And we can, if you have any questions as well throughout it, please let us know and we can help you get by as well. So, and then here we have, this is previous Reactor Lab that we did, but we're going to turn it back into a HashiCorp one. So this one is AKS. So for this one, this is where we'll be doing most of the work in the code today. Okay, so let's get started. So here you'll see that we have in our AKS, we have, I'll briefly go over Terraform and then I'll just assume that you know basic knowledge of it. So what we'll use today is the Azure RM, so Azure Resource Manager Provider. And in Terraform, you have the concept of a backend. So you can use a local backend or you can refer to the cloud. So you can use, console or Azure AWS GCP. You can store your backend in any cloud, even if you're provisioning to a different cloud as well. So that simply stores the state file, which is a ledger of all of the desired state for your infrastructure into the cloud. Here you'll see that we're just using an Azure storage account. So we're using, here we're defining a resource group, storage account name, container name, and then that will make that key when we use Terraform in it.
Yeah, just to add on to that, so the whole reason why we need this to be a remote state is because if you're working in a team and you say you have multiple developers working on it, you need the state file in order to ensure that when one user does something, that whatever has been deployed is stored somewhere, as compared to if you're doing this on a local state, which then so if I deployed something and the state file is stored on my PC, whenever Brad does any further changes, it's not going to register and you'll end up double deploying or overriding. So that's the reason why we need remote state. And it doesn't matter whether it's Azure, AWS, or GCP. It's just storing a TF state file, which is something that you can open with any code editor, and it just saves it somewhere. Brad, I think you're still on mute.
The next step, we have the concept of variables as well. So variables are obviously we declare them and we want to define the custom variables. So in what we've used here is we just have a demo TF-vars file. So there's a bit of a hierarchy in terms of variable files. So we have, you can see shared. So let's say I have dev stage prod test. If I know that some common variables are the same, then I don't need to, write them everywhere. I can just put them in the shared and that will pick them up after the other file. So here you can just see, for this one, we're just going to have actually called Terraform. We'll put demo here for the environment. And then this one here, normally we just like to tag things to say that this is where the code belongs when we deploy to Azure. And yeah, pretty simple stuff really. This is the subscription ID as well. The reason I wrote it for account is I normally use this code for GKE and AKS as well. So I keep it generic names. So one thing, so the first thing we do is we create a resource group. So, okay, so actually probably we'll go one step back. So what Ben and I like, maybe you want to talk about the locals, Ben, and why we like doing it this way as well.
Sure, yeah. Locals, the difference between using variables in the local side as compared to in a .tf-vars is when you do it in the locals, you can actually interpolate the way we're doing right here. As you see, we're passing in line number 9, shared name, we're passing in the client project ID, client environment. This interpolation is something that you can do in locals, but it's not supported when you do it in the tf-vars variable file. So it's, locals can also be used for other parts where you're pulling information from, say a resource that you've just created. You can pass in the ID into a locals thing to be, further transformed.
Yeah, and I guess this looks way cleaner than having to, if that's your standard naming convention and you have to do that, it does look quite ugly in your code. If you have it for each name of each resource and you have this, it doesn't look nice. But whereas if you just reference it to be primary name, it looks a lot cleaner. And when I was first starting out with Terraform, I would actually put this tag block in the demos file as well, in the environment file. And then I thought, well, we've already got this information in here. There's no point writing it twice in the environment file. So it's just a nice, neat way of using your variables as well. So once we've done our provider. The provider is the latest version of Azure RM. We've now done our variables and define our locals. Now you don't need to define locals. You could hard code everything if you really wanted to. And then now we need a resource group. So pretty much every service in Azure needs a resource group. So here you see this is where it looks nice. So instead of having client ID, client environment, client project, this looks a lot cleaner. And
it also helps that you only change it once in locals and it applies to every single resource rather than jumping through 10 resources and renaming them all at once.
Yeah, correct. Yeah, that's right. And okay, so one key thing to wrap our heads around is that this in Terraform you can use resource straight from. So for example, I could just copy and paste this. This is a resource, but because we like to, I guess, put guardrails in for developers not to do stuff they shouldn't, so to do unsafe things, we like to have the concept of modules. So these modules are just references to those resources as well, and they're version controlled in Git, so we can call them from here. You can see that I'm referencing that module Git repo, and that's going to pull those modules down so that I can use them. And you can actually specify a GitHub tag or release branch as well. We haven't done that here in this case. So that's one way that we really like to leverage modules.
Brad,
it's
could
good.
you just go into the resource group module in your GitHub for a sec, so we can show what we mean by the version controlling and enforcing certain things. So in this case, what you see here is it's not just a resource group that we're creating. We're also creating a consumption budget. So when you create this resource group, you're passing in a few parameters such as what's the budget that is allocated to that resource group on a monthly basis, and who should you send a notification to if that budget is exceeded. So these two combine together, and if we go back to the module resource group that you had before in the other code editor, see this one module Azure RM resource group, it actually creates those two resources at once, and it's quite clean. It abstracts away all the excess information. You just pass in resource group name, location, the budget amount, and it goes away and creates those two resources that you just saw.
Yeah. And you can see that in this one, if you put the budget amount to be 0, then it's not it's using the count capability, so it won't give you the budget if you don't want it. Because in some use cases for free accounts, sometimes it doesn't let you do budgets. So not everyone has them, but yeah, this is how you really leverage modules, because it doesn't just have to be like for like. You can add your custom things in here like we have. Yeah. So now we've got the resource group, we have something that we can put the resources in. So here, now that we've got our resource group, we'll probably go with networking next. Generally we want to set up our foundations. And I just seen someone on the chat. Thanks for organizing this. Looking forward to learn. Was it in Meetup? Yeah, it was in Meetup. Yeah, and yeah, if you have any questions throughout, please let us know, and I'm more than happy to show you something. Thanks for that. So now let's do our networking. So depending on what sort of environment you want, if you're using App Gateway, you could do a subnet for that as well, but that's very expensive for us, so we don't like it. So we generally don't use App Gateway. But here you can see that I've just got a VNet and subnet for Kubernetes. So if you have a private Kubernetes cluster, then you might want to do a bastion as well, where you can, if you need to use kubectl to talk to the cluster, then you have to VNet pair this network as well, which I can show later if we have time. So yeah, and we define, you can see we're defining our ranges here. So we're going to use this block here, and then the subnet, we're going to split it here as well. So generally, what Ben and I follow is AKS baseline multi-region. So let's just have a quick look at that. Let's see if it comes up. Yeah, here it is. So this one is just showing like a dev environment, because we didn't want to show too much at once, but because otherwise it's confusing. But essentially, this is like a production picture. So we have multi-region private clusters. So you have to go into the bastion host if you want to talk to the cluster. And then the thing that we take out of this App Gateway, because it's just too expensive. And we have the container registry and Azure front door going into it as well. So for what we're talking about today, we're really just talking about this spoke virtual network. So we're simply just putting the Kubernetes cluster in there, and then we're going to put a load balancer on it to be able to send requests to it. Is there anything you want to add on that, Ben?
Nope, that pretty much covered it.
Okay. So yeah, you can see we have our IP ranges here. So once we leverage the modules, that's our VNet subnet laid down. So we've done, that's ready to go. And you can see a cool trick we're doing here is we want to put governance around tags. So in cloud engineering, we want to say, okay, you have to use these tags, and then the developers can also put in their custom tags if they want that relate to their domain or their project.
While we're here, I'd like to add something to when you look at on the left of the screen, you see how there's, say auth.tf, network.tf, keyvault.tf. When Terraform runs, it doesn't run them in a specific order or on a per file basis. All the TFs that you see, they all get mashed into a single file when Terraform runs it. So it doesn't matter the sequence, whether you put, like when I'm seeing on the screen right now, whether you have virtual network primary above or below the Azure RM subnet, Terraform itself would know to which thing works on which. So as Arvin, you mentioned there, the depends on virtual network primary name. So let me see here. This actual instance, you don't actually need the depends on, because you're already referencing it on line 13. That itself tells Terraform would interpret that to mean that this subnet Kubernetes itself would need to be done after virtual network primary is created. So
yeah, that's
right call out. Yeah,
you don't actually need that, because you'll see in the cluster we're referencing the subnet ID. So Terraform will work out the subnet ID. So Terraform will know, okay, I need to make this subnet before I make the cluster. So yeah, you're right. That's a good spot. I think I was using that for a demo before to demonstrate the depends on. But yeah, you're absolutely right. You can take that out. Okay, so yeah, network's done, and then I guess let's go. When we use a private cluster and we want to have a jump box to talk to it, we have key vault. So I've commented that out for now, but essentially this is quite cool because we generate an SSH key and then we put it in key vault. And when you use the Bastion service, you can just go in there and then you select the ID from key vault, and then that will authenticate you into the jump box to connect to the cluster. So that's, if we have time, we'll do a private cluster. And so now let's get into the Kubernetes. So yeah, really, this is the TLS private key that we use for the private cluster. Today we'll just do a public one because it's, nice and easy. Maybe there's some people, if this is the first time spinning up, so we don't want to get too complex. So here we have, we'll go back to the modules folder, but essentially this is a Kubernetes cluster that I've made. It is compliant in Azure, so it doesn't get any red flags or anything for recommendations. So let's go back into the modules folder. So Kubernetes cluster, and then this is an example of, for the Kubernetes API server, you can also do a, here you'll see in the comments that you can whitelist saying only IP addresses from here are allowed to talk to the API server. So that's somewhat of a private cluster as well. Generally in production, I use down here, private cluster enabled is true. So on this demo, we'll just say false because it's easier starting off. And then in Azure, for some reason, your node pools need to live in a different resource group. Not sure the exact reason why, but generally you'll see that, well, always you'll see that your cluster will live in one resource group and then the node will be another one. I like to overwrite, well, I think this is by default anyway, but I like that it's just -node because it tells you what it is. Did you know that, Ben?
Yeah, it creates, I know it creates a second resource group. I don't recall off the top of my head what the default group is called.
It's this one, but
yeah, it's just the -node.
But it's a bit, I would almost like it in the same resource group, but anyway.
Yep.
It must be for some sort of reason. And then here we'll see the default node pool. So you can see here that I'm using auto scaling as well. So I'm saying the minimum count that I want is, and this is hard coded, so I can actually parameterize that as well, because generally that's what we use starting off, but you might want to have more nodes in that. So that will auto scale up and down, which is quite cool. Identity, I used to use the service principal, but now you can use identity, which is cleaner. And then for the network, you can use either Azure, CNI, Kubernetes, Calico. It depends if you want. Yeah, if you want to use Calico, some people like that when they go cloud agnostic, but if you're always in Azure, you might want to leverage Azure CNI, because that will give you more integration with Azure. It makes it, you can really leverage the cloud more. Yeah, so do we have any questions regarding that community? So let's maybe go to this is what in Terraform. So this is like the shopping list of variables that you need. And then, yeah, it says here, always use the latest version because it's changing so much. But you can see here, it's a little bit different. But you get all of your variables that you can put in here.
When you first look at one of these resources, they can be a bit overwhelming because there are just so many parameters that can be passed in. So typically we start with kind of a bare minimum one, and you add on as many of these optional ones as you require when you actually require it. Otherwise, it's just too many things to pass in at once.
Sometimes we even go as far as doing it in the console, making an ARM template and just looking and it's sort of matching, right? Like, because sometimes you just don't know what one to use. But
correct, yeah. Especially for things like SKU names, it can be very specific to Azure and certain casing or whatever they call the SKUs. So it's sometimes useful to just look at the ARM template and copy that exact SKU.
So there's another question. How are we declaring the pod side range of Kubernetes? So I think this one's using Azure. So let's modules. Yeah, that one's using Azure, but if we, that's a good question. Let's look at that now. So for Kubernetes network plugin,
might just be network plugin. Or, no, it is.
Hold on, I'll look in the modules. It's down here. So okay, network plugin, network protocol. Okay, so network plugin to networking currently supported by Azure Kubernetes. Changing those forces new. So when network plugin is set to Azure, the network subnet ID field in the default notable block must be set, and pod side must not be set. So yeah, normally you can click on this, but it looks like for the profile in here, if we go down to pod side optional, so decided to use the pod IP address as the field can only be set. And yeah, so yeah, when we declare it, so you would put pod IP addresses, and then you would set that. To keep it. So you could come here to the modules and then put, let's say here.
Oh, that sits inside the network profiles.
So, yeah, no, I'm just putting it there to copy it again, but he understands, yeah. So maybe just for the others will put. And then you'll just, actually that would be in a row. With the addresses and then keeping it as well. But yeah. So yeah, so we can probably start spinning this up. So just doing this prefix. Let's spin this up and then take a look at what we have. For role assignments as well, the cluster needs network contributor to do its business when it's provisioning. And then also, if you have a container registry as well, you can put a role assignment then, so then it has access to the container registries. Or also DNS, if you're using DNS in Azure, you can reference it there as well. So yeah, that's pretty much going through the code. Now let's see if it works. So as you know, Terraform, to initialize the backend, that will pull down your provider, that will pull down all of your modules and things that you need. And then you can do a plan, or for me, I just normally do apply because it's the same. You still get asked yes if you want to proceed. And then, so here I'm using demo. And then you can see up here that, yeah, in my folder, I have deployment demo. And that will then go give me my plan and say, okay, so bashing cloud 2. Okay, so it looks like because I've cut this version down, I've got what it's saying here is that there's no value for in the variables folder. So anything with cloud location 2, we can take out. This is when we're doing multi-region. And I think there's a couple more errors that I'll quickly fix now. So it looks like we're not leveraging, initial node count. So yeah, I think because we hard coded it over the other side, which we should know, but let's have a look at our Kubernetes one and see what we're actually using. Kubernetes initial node count.
Right, we just didn't put it in the TFRs, I think.
Yeah. Okay, so let's do that. So we'll just come down to shared, see if that's the and then so yeah, it's not in shared, and then in our demo as well. So we've got to add all those too. This is a good example.
Oops, I think you broke your public CIDR one.
Yeah, thanks. I was wondering what that was. But initial node count can be 1. See, it's actually hard code, so we'll fix that soon anyway. If anyone wants us to show that. And then node size. So it won't be a second, I'm just going to grab the machines that we're going to use. So generally I keep my VMs about 16 gig of RAM, but you might want to keep them smaller or bigger depending on how much workloads you're putting in there. So yeah, here you can see I was missing here. So no disk size network policy, instead of Calico, we'll just use Azure TNI. And then for node size, I'll just use E2 standard 2. And then to be consistent with what we have in the other one there. All right, so that should work. Okay, and this is Ben's magic he likes. He likes to do the
Validation.
yeah. Do you want to maybe talk a little bit about that, Ben?
So yeah, this particular validation, you can see it in the variables.tf. This is more hard. It should be the very first one. We do a bit of these validations. So we use client ID in a way for the devs to name their project something that's more specific. So you wouldn't be able to call your project your TF-app service because TF itself is not very descriptive. We tend to give it names like I don't know. This could be the client front end or the something back end. So that's what client ID is used for, and this is how you can use validation to ensure that your descriptions are descriptive enough but not overly verbose. So in this particular scenario, we can just get rid of the validation because, well, it's a demo.
Yeah, I mean, we could put maybe over 1, for example, but
Mhm.
generally we find validation is good, but sometimes it's annoying.
It does get in the way in certain scenarios.
Yeah. But it is a good safeguard because, some Azure services only have 13 characters, or if you have really long project names or client names, then it'll just break. So it's finding a mix with validation and putting it and not putting it.
Key vault is one of those examples where it has, I believe, a 24 character limit. And that's why we sort of went with 13 character, well, maximum of 12 characters for the names.
And storage accounts are annoying as well.
Storage account doesn't let you do anything other than alphanumeric, which also gets really ugly namings.
So see here, this is our plan. It's same as apply, but and then we're doing 6 resources. So we're doing our cluster, and then resource group, role assignment, subnet, VNet. Yeah. So let's see if we get an error. Hopefully, then we can explain how something works. So what Terraform is doing now is it's polling the cloud, saying, okay, do you have this resource in the cloud? And then if it doesn't, it will create it. And then keep a record of that in the storage account that we defined in the provider file. So generally, doing a cluster will take about 10 minutes. Okay, so we have 1 error already. VM size not supported. Okay, it's not supported for that subscription. So yeah, this sometimes happens, which is fine. So I guess now we go back and we look at the Azure VM sizes and see which one.
Yeah, this is exactly the type of stuff that you would usually get from an ARM template, or when you try and deploy in Portal, you get this specific name. So it wasn't E2 dash whatever we had used before. It's one of these standard D stuff.
Yeah. And when you do like free accounts in that as well, sometimes they're different. So generally, you'll probably get this error. So it doesn't look like this is going to time you standard. It's a bit annoying actually. So yeah, you can see here, it's strange that it says previous versions, isn't it?
This is the standard A, seems to be the old stuff. Standard D or standard B is the current gen stuff.
So it's on well, for now we'll just choose on pretty fast, but yeah, it gets annoying. So we need to do one that is, what are we going to go for? Just this.
Is there like a B4MS or something along the lines of that?
How about if we just go, what about, so you're getting into pricing. Let's just go simple. We'll just maybe do that one.
Yep, that looks decent enough. Standard A4.
Yeah. So then we go back to our variable file, and this is the beauty of variable files, is that you can change it in it all. Just one change. So let's see if it likes that.
Nope, Arvin. Unfortunately, IntelliSense isn't the library doesn't support these acceptable sizes yet. They just tell you that it's expecting a string, and if you give it a number or a boolean, it gets angry at you. But it doesn't give you.
There might be a linter as well.
Yeah, and this time it's only adding 3 because it's already created the VNet and the resource group and one of the other ones.
Yeah,
rather than the 6 from before.
Because it's looking at the state file, and then it's looking at the cloud and saying, okay, this is my desired state, but you have this, so I'm going to now provision this cluster again. So yeah, that's, if anyone's trying this themselves, that's probably one problem you possibly have, is the sizes. But yeah, I probably, because I was doing that fast, I probably would have liked to know how much that actually costs, because in Azure, as you know, Ben, like the pricing can vary so much, and one small change can make it cost crazy. I know.
Yep. Going up a tier doesn't always mean just doubling in cost. Sometimes it can be quadruple or even 10 times more expensive just bumping up one tier.
Yeah. So yeah, that'll probably take possibly 10 minutes. It depends on the workload of Azure, what people are doing at the moment, but it shouldn't take too long. And then if anyone else has any questions, we can go through them. Maybe a cool thing as well is we use TFSec for static code analysis as well. So that's a project by Aqua Security, which I really recommend. This will scan all your code and see if you have any vulnerabilities. So we'll actually keep ourselves honest, and we can run TFSec on it as well, just to see that we don't have any vulnerabilities. So we normally run that as well. And then we don't have our Azure DevOps pipeline here, do we? Then we should put that in there as well.
No, we don't have that in this particular repo, I believe.
We can do another session on that. And then I started making a GitHub one, so don't need that anymore. So what I like to do is just normally have like little bash scripts, because that's portable over Bitbucket pipelines, Azure DevOps, whatever your CI/CD process is. It's easily portable instead of using actions and stuff or workflows. It's it sort of ties you in. So we just download the latest version of Terraform in this Ubuntu image. We reference that as a secret in our GitHub. Technically, I mean, that could possibly be deemed as a secret, but to me it's not. But some people might think Tenacity is a secret. and then we did what we did on just before, so Terraform init, that will pull it down to the build agent, and then you can see we're just finishing off, which we're putting we use OPA, so Open Policy Agent, for validating our Terraform as well, which is quite cool. So in that stage as well, later on today, we'll add that in there too, and then obviously apply. So you can see that if you push to main, this workflow will be triggered, and then that can, providing it passes all the tests, like are you deleting a cluster, or does your security vulnerabilities match, then it will pass. So maybe later, Ben, you can show your Azure DevOps pipeline as well, which is quite cool.
Sure can. Yeah, so the two things that Brad had just mentioned, TFSec and OPA, they do quite different things. TFSec, that static code analysis, it pulls resources from, I believe it actually references Azure themselves, and you get stuff like if you're a storage account, check and ensure that it'll give you warning saying your storage account doesn't have any firewall rules set on it. So in theory, your storage account is publicly accessible, and you still need a key, but it's one step away from being more open. And you've got a whole bunch of other warnings as well. It sort of does it in low, medium, or high, or even critical warning levels. So different things could give you. It's angry.
That's fine. So that's good, because it's really good, because this is what real life looks like. So that's fine. So at the moment here, we'll see. I'll just put the screen back. So what's this one saying? So in the Kubernetes cluster, it's saying in that subscription resource group, this is the node resource group that it makes. The managed identity, parsing segment, static resource groups, expected the segment resource groups, to be resource groups.
There are times where Azure does this kind of weird stuff where it's just casing.
Yeah. So let's now go look at the module. And then the resource group name I'm assuming in should have just been module.resourcegroup.name, and then you can see my outputs here. Name. That looks good to me.
That looks like the ID though, not the name, because that's the whole /subscription stuff all the way down.
Yeah.
TFAUSE demo agent pool. So it's expecting segment resource group to be resource group.
Okay, so let's just look more. I mean, my assumption is it's possibly that, but let's have a look. So how we troubleshoot this? I mean, it's a pretty weird error, but my first hint would maybe be something around that. And I've just used this recently as well, so I don't quite know what that means, but why this doesn't work. But let's look at the docs, so resource group name. And this is something we need to look out for as well, because it changes fast. So you can actually hard code versions of Terraform as well, or providers so that we won't have this problem. So let's look at resource group and see if that's any hint. That might not even be the issue. It could possibly be that because we're using node resource group, the auto-generated resource group, which contains the resources for this managed cluster. So I could probably even take that out, and maybe that would fix the issue. I might just do that, and then if it's not that, I'll just try something else as well. So see here, I'm going to have to actually commit that as well, and then do a Terraform init to pull that back down again. Sorry. So now that I have pushed those modules back to Git, the cool thing is that over here, generally for safety, I just delete this folder because that's where your modules sit once you call them. And then I can just go Terraform, and that will pull them back down again. But there's actually a cleaner way as well, I think, Ben, to pull your modules again.
Yeah, it's in the dash either update or upgrade. It's one of those two.
I couldn't remember, so I just did that one.
Yeah.
There is a cleaner way to do that. That's a bit of a rough way. So yeah, so that's possibly what I'm thinking is the error there, but we can also look at it. So resource group name required. Yeah, I'm going to do actually, I think I might know the issue because that is local.shared name, and then that's local.primary name. So that's, see what I've done wrong. So
I think you actually have both in your locals. You've got a shared and a primary.
Yeah, so that will be saying, so shared is this, and then primary is with the location. So what's happening is, because I'm referencing, see here, my name, it's just been a dot, like I could have done it better. So see in the modules how I'm saying down here, var.name is node. That should actually be resource group name. It's just bad. So this would actually work here. You can see, because that doesn't have the location. So that's the issue. But regardless, with that commented out, that will still work because the error was actually my referencing of variables there. So now let's apply that. And also, if what we do as well when we do releases like that, we would make a release branch and tag it, and then over here for referencing that module as well, you can just put a parameter. I think it's ref equals like the version number you give it, something like that.
Yep.
Yeah. Is that exactly what it is?
Yeah, that's how it is. Ref equals whatever the tag name is.
Yeah. All right. So still an issue. Let's go back and we might. Okay. One thing we'll probably do here is go Terraform destroy. So this is what you can also do when you want to finish, like if you want to just test this out yourself and see if it works, then at the end you just go destroy. So this is a good example of using destroy as well. I do like in these demos when things do go wrong because that's the real world, to get with. It's never as easy as just when you're making this stuff, apply and it works.
Things always break.
Okay, so see that this is like stuck. Have you ever had this issue, Ben? So it's freaking out because it can't apply or destroy, so it can't go back or forward. So what we'll do now that that's like that, I'll just commit that as well. And then here you have a lock, but you can delete that as well. You can go like get pretty rough, and let's just try to do it properly for like clean. It's always sometimes in Terraform, I find that if you get a real big problem, you can spend a day fixing it. Obviously, if it's production, you have to do that. But if you're in dev, you can just be rough and just delete the state file and delete the resource script and do it again. Sometimes you do get weird problems like that.
So this is actually an example of when the version pinning might be useful. This is currently a known issue of the Terraform Azure RM provider. In this current version, that it's having this bug.
Oh, is it? Oh, so
yeah, it's actually the Azure RM version that broke it.
Oh, okay.
Right now we're at 2.88.1, and what I'm seeing is 2.87 is the one that works. So it's a new bug caused by the rapid deployment of Azure providers.
Oh, okay. Yeah. Yeah, it's funny at interviews whenever I want to know if someone knows Terraform or not, I say, what challenges have you had with Terraform? And if they say no, then I know that they don't know how to, they don't know Terraform.
They haven't used it enough.
Yeah. It looks like this is going to work now. I hope. Otherwise, we'll just delete it and then we'll just initialize it and apply it again, and it will work. We can get it working. And if anyone has any more questions, please let us know. If there's, we're more than happy to help you set this up for you if you want. Just reach out to me or myself. Or if there's any other module that you want added, we're more than happy to add a module as well. So I think when the hour's up, we'll probably have this all deployed. So I hope this has been a good real-life demo of, of using Azure provider, Azure RM, and Terraform. Do you have any other comments, Ben, on your experience so far?
No, so far it's been good. It's more knowing what issues tend to happen with these providers and how to get around them. So one of those things that I had a lot of issues with in Terraform was getting the object ID of certain things, like say a function app or an app service, and granting that particular object ID access into a key vault. I've actually encountered a few times where it sort of became a circular reference thing, that the key vault is waiting for the app service to deploy and the app service is waiting for the key vault to deploy, and it's sort of gone around in circles, and you had to force it to deploy one manually before it's allowed to deploy the second one. So in a way, it's a lot of experience that's needed to understand the quirks of how Terraform works and how the whole dependency chain works, and writing your code in a way that avoids these kind of circular references.
Yeah. I guess for production, it would be good to pin the version of the provider as well, because when it was, back in the day when I would use the Azure AD provider, which is the Active Directory one, that was very flaky as well. So they wouldn't work good together, the Azure RM and Azure AD. So I guess it's fun. It's chicken and the egg, because it's like, do you want the latest security updates and features, but you don't want to break it? So I guess you can hard code it, test it locally and on other environments, and then sort of bring that through each time there's a new provider come out.
And we are having quite a bit of fun going with Active Directory, Azure DevOps, and Azure Resource Manager all at the same time. So that's quite tricky to navigate between technically 3 branches of Azure, but they have some dependencies that are unexpected. So you would kind of want to separate your repos to not use more than one provider at once, if possible.
Yeah, yeah, and that's a good point, because when I was first learning Kubernetes, I knew Terraform first, so I spun up my AKS with Terraform, and then I would use the Kubernetes provider, so you can do deployments and stuff with the Kubernetes provider of Terraform. But that caused even more problems, because if you've got an issue in there, that would break your whole deployment. So you couldn't even change your infrastructure. It was just, yeah, I agree. Like, I recommend just use one provider at a time if you can, and then it's not going to break your whole deployment. So you can see that that's now destroyed. So that fixed our problem, and then I don't anticipate an issue with this one now. It should all spin up nicely. So we'll be able to show you it spun up before we finish in 8 minutes, well, 4 minutes.
Well, speaking about the providers, there are some pretty useful ones that are created by Terraform. Like, is the SSH key one by by HashiCorp, or is that not? Is that a separate third-party one?
No, I think it's a HashiCorp one. So utils.
Yep. So TLS private key, that's quite a useful one that we've been using. So this particular resource, what it does is it generates your standard SSH key. You've got your public key and your private key, and as a result of that, you can store the private key in a key vault or HashiCorp vault, or whichever secret management provider you use. So this TLS private key is a useful one. Random string, random password, those are also other things that are default from created by HashiCorp, and they're quite stable. We've never had any issues with them thus far. They're good ones to use.
Yeah, especially for when we make passwords and then inject them into like Key Vault or somewhere as an app configuration, and then that can be referenced. That's been quite handy, hasn't it?
Correct. Yeah, we just generate a password straight in Terraform. Don't need to store it anywhere else. At no point in this whole process does a human actually see the password. It just gets stored straight in.
Mm. And then in our modules, I've got all Bastion and host Bastion servers. Maybe we can do another one on creating a multi-cluster next time. So essentially, it's a bit of copy and pasting, and then we can put Azure Front Door connecting to it as well. So if anyone's interested in multi-region, you can also do your cluster with node pool over availability zones or location zones as well. That in GCP that generally costs more money. So there's different types of high availability configurations you can use. But yeah, if anyone wants us to do a specific talk on any of those, let us know, and we can do that. So it should just be a couple of minutes, and then this will be created. So I guess in summary, we talked about the provider. This is the backend that we're using. We went over variables, so this is where you declare them. Validation is good and bad. Use it where you need it, and then I wouldn't really worry too much about it. And then we talked about the shared auto vars, so that will be over all environments, and you can use environment variables as well. So I think then it's capital TF.
TF underscore var, all in capital. TF underscore var underscore then the name, like in this case, client ID. And I believe it's all case sensitive. So even if your TF underscore var underscore, that's in capital, the client ID would be in lowercase in this instance.
So that will override variables as well, which is even more flexibility. And then we talked, this is because I'm not doing it in like a CI/CD tool, but this will essentially bring down my modules, which are referenced in the other repository, and then the provider, which is Azure AKS. We don't worry about that because that state is remote. And yeah, pretty much that's an introduction to deploying AKS Cluster. You can see that there's a lot of configurations that you can specify as well. And it looks like our cluster is done, which is very cool. So now it's doing the role assignments to that. And then in about a minute, we should be finished.
Right on time.
Yeah.
It's like we timed it perfectly.
Yeah.
All part of the plan.
Yeah, so you can see now that all of our configuration is deployed. So we can then authenticate with the cluster like this. So that's a different one to what I use, but I'm going to change it in the outputs. And then you'll see, I mean, do we want to quickly look at the, I guess it's good to look at it there. Otherwise,
Yep.
we can't show what we just done. So you can see
TF
here
demo node.
in TF demo mode. And then we've created our virtual net, our VNet, and then this is our cluster as well. So yeah, that's Azure CNI, that's our side blocks. And yeah, you can see our tags as well that we used. And yeah, that's
Let's quickly just flick over to the node resource group just to show these are the resources that are sort of Azure Kubernetes managed. The demo node, that one under it. So those are the ones that has to be created and is managed. I believe, if I'm not mistaken, this is also locked, so you can't actually do anything directly to it because that's managed as part of the Kubernetes service. Yeah. So if you actually try to delete, say, the VMSS, that skill set, it's not going to let you do it because it's tied into the other stuff.
Yeah. And yeah, thanks, Arvind.
Thanks, Arvind.
And if you ever want to do one of these talks, you're more than welcome as well. You can, we can do one on Terraform, or yeah, feel free to reach out to us. So yeah, thanks everyone. See ya.